Welcome back, focused learners. I'm so thrilled you're joining me for another explainer today, because honestly, we are looking at something that fundamentally challenges how we interact with autonomous systems. We're talking about Perplexity's newly launched brain system for its computer agent. Now, up until now, whenever we've talked about AI memory, we've basically meant the AI remembering you, right? Like your preferences, your tone of voice, maybe what city you live in. But Perplexity is marking a truly fascinating shift here. See, brain doesn't care about your favorite color. It cares about remembering the work. It remembers what the agent actually did, what succeeded, and what completely failed. It's a totally different paradigm, and we're going to break down exactly how the whole shebang works.
Okay, let's dive into this. Here's our roadmap from today. We'll start with a new AI memory, move into building the context graph, look at learning while you sleep, cover measuring the impact, and wrap up with strengths and open questions. Let's get right to it.
Section 1. A new AI memory. To really understand why brain is such a big deal, we need to look at how Perplexity is reframing memory entirely along two distinct axes: what the memory is about and what it's actually for.
I actually want to pose this directly to you. What is AI memory actually for? If you've used any standard chatbot recently, you probably assume memory is just there to make the conversation feel, more natural. You want it to remember your birthday, or that you prefer your code written in Python instead of C++, or that you like a really casual writing style. We've been conditioned to think of memory as this tool for personalization, but Perplexity is asking us to completely throw that preconceived notion out the window.
And this comparison brilliantly illustrates that stark contrast. Traditional user memory is entirely about engagement. It creates a profile of you so that you feel more connected to the agent. Brain, on the other hand, is a work memory. It is laser-focused on performance. It doesn't build a profile of you at all. It builds a profile of the tasks it's completed. It logs the agent's past actions, tracks exactly what worked, and meticulously records corrections. Its sole purpose is simply helping the computer agent get better at its job. It's a major shift from an AI acting like a friendly little assistant to an AI acting like an evolving operating system.
Let's move to Section 2, building the context graph, and see how this builds into the actual engine powering this entirely new type of memory. So how does it store all this? The answer is the context graph. Think of this as a living, breathing LLM wiki that gets automatically loaded right into the agent sandbox. Instead of just pulling from some static, flat database, the computer agent traverses this automatically generated web of information. It's literally like a map of a user's entire world of ideas, the people they interact with, and the ongoing projects they're building. By structuring the memory like a wiki, it gives the agent a highly structured, interconnected landscape to navigate before it even starts a new task.
Now, the crucial point here is traceability. This is not some black box where the AI suddenly just knows a fact and you have no earthly idea why. Every single node in that context graph, every single memory entry, links directly back to the session, the specific file, or the exact source document it came from. From an engineering and user standpoint, this level of traceability is absolutely vital. If the agent makes a mistake, you can trace it right back to the source memory and debug it. It builds an immense amount of trust because the AI is literally showing its work.
All right, moving on to Section 3, learning while you sleep. Because, let's face it, an LLM wiki is only useful if it stays current. So how do they update it without interrupting your day? They use a process called overnight synthesis. Here is a day in the life of this system. Step 1, you just run tasks normally with the computer agent. Step 2, when the agent hits a dead end or you step in and correct a mistake, it logs those corrections. Step 3 is where the magic happens. Overnight, or at set intervals, the brain system kicks in and synthesizes all those user sessions, connector results, and corrections to update the wiki incrementally, which perfectly sets up Step 4, improved performance the very next day. Perplexity explicitly frames this feedback loop as an investment. The tokens you spend today correcting an agent, that's an investment for much smarter, far more efficient token usage tomorrow. It doesn't have to relearn the exact same context twice. Section 4, measuring the impact. Theory is great, but as focused learners, we obviously want to see the data, right? Let's transition to the hard numbers. Keep in mind, these are early, first-party results from Perplexity's own internal testing, but they paint a very clear picture. Now, what's really interesting about this slide is this massive jump. Perplexity is reporting a 25% increase in answer correctness on tasks the computer has seen before. And that makes total sense, right? Because the agent already has a mapped-out context graph of the successful sources and previous dead ends. It starts the task from a significantly more advanced position than if it were starting from scratch. Building on that momentum, they also saw a solid 16% increase in recall on those same early results. When the agent is tasked with finding specific information within a complex workflow, that updated LLM wiki ensures it knows exactly which conceptual threads to pull to retrieve the right data. It isn't just searching blindly, it's navigating a highly refined, personalized map.
And here is the metric that is absolutely going to turn heads in enterprise environments: a 13% reduction in cost. Because the agent is learning from its past mistakes and dead ends, it requires significantly fewer turns and fewer model calls to reach the right output. It's simple math. Better memory literally saves money by optimizing compute efficiency. To prove just how broadly applicable this work memory truly is, let's look at 3 concrete use cases. Imagine a data scientist running a weekly pipeline audit. Brain remembers the reliable data sources and past corrections, so next week's audit starts with way fewer dead ends. Or take a support team triaging tickets. Brain learns which documentation resolved past issues and just automatically routes future tickets faster. And for a developer debugging across massive repositories, Brain remembers which files were the root cause last time, meaning the agent can diagnose the issue with far fewer model calls. It's a highly practical, across-the-board performance boost.
Section 5. Strengths and open questions. As with any emerging tech, it is absolutely crucial we take an impartial reality check. Brain is a powerful concept, but it's currently rolling out only to Perplexity Max and Enterprise Max subscribers in a research preview.
When we look at the full picture here, the strengths are highly compelling. We have concrete performance metrics, highly traceable memory entries that build trust, and a system that boldly targets agent performance over simple user engagement. But objectively, there are some open questions we have to acknowledge. Those impressive numbers we just looked at, they are first-party. We don't have independent third-party benchmarks yet. Furthermore, that overnight synthesis means improvements arrive on a delayed schedule. It's not instantly updating in real time. You literally have to wait for the sync to see the benefit. I want to end on this really provocative thought drawn directly from the source material. As an agent meticulously maps out every single idea, project, and correction across your entire workflow into this persistent context graph, it inevitably raises some serious data governance and privacy questions. Like, who has access to that graph? How exactly is it secured? What you should really take away from this explainer is that as AI shifts from being a helpful little chat interface to a fully autonomous worker with a permanent memory of your business operations, the way we manage and secure that memory will become one of the most critical tech challenges of the next few years. Thank you so much for diving into this structured breakdown with me, and I highly encourage you to keep questioning how these systems are reshaping the way we work. See you next time.